This video looks at the energy program and how to interpret the results. So having set up the building model from the previous videos, on entry into the energy program, the program calculates the rooms. Now the gains and losses on the rooms are purely determined from the default in edit general plant. So the numbers will be run based on all of these standard defaults that you get on the dialog boxes. So as an engineer, you have to reflect your design intent by making certain selections from these dialog boxes. So for example, you have the building weight, lightweight or heavyweight. Mechanical ventilation timed. That implies the timings on the room profiles will be applied and the timings on the heating plant and cooling plant also. So for example, if you're doing a domestic property, likely as not it would be none. If you're doing a hospital or airport, 24-hour operation, perhaps continuous, or factory or an office, then timed. So you can draw the distinction on the operating times of the plant. Lights off in day, that means lights are going to stay on during the day. There are dimming controls, that's more of that in the lighting videos. Building usage speaks for itself. Calculation basis air temperature, there are two different basic calculations, air temperature and dry resultant to the CIBSE Guide A5 method, which you will be familiar with. Should you tick any boxes in any of the room spaces implying that you will have underfloor heating or you want to put radiant panels in those spaces you can apply the dry resultant temperature. Generally you would apply air temperature unless it's a fully radiant system, of course. We then have the heating tab. This is your design outside temperature. This temperature is taken from the weather database. This can be altered at this point, so you can put any temperature you wish in there. The supplier delta T looks at the temperature between a local unit and the supply temperature onto the unit. The option here is the air treated. This is quite important because this can determine and will have a bearing on the load within the room space. So first of all, we'll deal with the scenario where the air is untreated. Here we can see a not untypical setup where you have the room spaces provided by central air conditioning or air handling plant. And we can see here that we've got the room load applied to the space. Now you can see the little caption at the bottom there, is air treated. If it's not treated, effectively what you're doing, you're ventilating air into the space totally untreated. So you are relying on the air handling unit to provide the complete duty on the space. So by entering is air treated no, that's going to take the outside temperature of -4, it's going to look at the various room spaces, and then it's going to look at the simultaneous requirements on the air handling unit. It says cooling here, but the same applies for heating. So in point effect, if the air is untreated, so if you don't tick the box, is air treated unticked, where the mechanical ventilation temperature isn't entered, then you are bringing air in this case, -4 degrees, up to the room temperature of 20. So you have a delta T of 24 across that entire system. That will then determine the load on the central plant. If we now look at a situation where we're actually treating the air, you can see now the caption entry on the dialog box is the air treated, applying a tick implying yes. You put the mechanical ventilation temperature as an off-coil condition. So if you've got a -4 temperature coming into the space and your off-coil is 13, then you have a 17 degree delta T. That will size the heater battery based on that situation, leaving a remainder in the space, which you've then got to offset with either radiators or local fan coil units. So the entry is the air treated has a bearing on what you're doing with your fresh air into the space. Now, this could apply to local cassette units or local units. You might have local units underneath a window or local to the space, or a DX system or a chilled water system locally. The same would apply. If you are directing air onto the back of those units which is untreated, whether it's via distribution ductwork or whether it's directly from outside to the space, then the same will apply. So what we'll do, we'll look at a set of results first for untreated heating and cooling. You also have the night setback temperature on your heating system. You have the plant times, your operating times. So in this case, the heating season is between October and April. Goes on at 9, off at 5. Those times can be changed. And you have your preheating. Also, you have the convective heating. This will have a bearing on the percentage convection that you're using on whether it's radiators or fan coil units. Here from the manual you can see the types of heat appliances, whether they're predominantly convective or predominantly radiant. Typically if you're using radiators you'd probably have 80% convective, 20% radiant. So you can draw the distinction as your percentage convective heating based on the appliances that you intend using. The same principles and parameters are applied to cooling. So in this case again we'll look at the results with direct ventilated fresh air from outside using the temperatures from the weather database. So in this case the cooling is driven by the weather database for the peak months of the year, which is usually June, July, August, or July, August and September. So you may well be ventilating air into the space at 28-30 degrees, which will obviously have a bearing on the gains to the spaces, and then you decide whether you're going to pre-cool the fresh air as explained previously. And again you've got the operating plant times for your air conditioning and your cooling. You can analyse peak 3 months. You also have your diversity or your zone diversity for occupancy, and the fact that you may want to apply the latent loading to the ducting and piping programs. You have the heating plant, where you've got your central plant efficiencies. You may have a more efficient system. Peripheral, fan coil units, radiators and ventilation. You have your predominant fuel type for your heating with your fuel price, and whether or not you want to offset any of the heating by the people, the lighting and the equipment. So if you've got a large process plant, for example, where you can guarantee you're getting a heat gain to the space, you could apply 100% of your equipment gains to that space. The program will automatically apply lighting should you wish to do so. Once the lighting design has been done by the electrical engineers, on moving back to the energy program you will get a caption asking you whether you wish to update the lighting gains or not. You may have started with 8 watts per meter squared. The engineers then import the lighting information. You may wish to update, so you get a choice as to whether you want to use the ad hoc value that you initially estimated or the actual gains from the actual fittings as part of the design. Cooling plant tab is the same principle. Obviously when you're looking at cooling you will include 100% of the people lighting the equipment, but you do have the option not to. And again you have the central plant efficiencies and the fuel prices, which you can adjust. So let's look at a set of results for a typical space that is not treated. Selecting the room, we see the room name in the corner. We then go to the display menu and we'll look at, first of all, individual room gains. There you can see the gain to the space presented in a linear chart. You can view that numerically. The peak of the space and the time of the space is always highlighted with a yellow banding, so you know the worst case scenario. You can also view it as a bar chart. And we also get the predicted summertime temperature for that space based on the fact that we're ventilating air into the space. Fairly high temperature in July, might be 28, 29, 30 degrees, 10 litres a second per person, single glazed or double glazed clear glass windows with all our gains contributing to the predicted summertime temperature of, in this case, 43 degrees. If we go back to the heat gain, we can look at different months of the year. So we can see in this case August is the peak month. If we wish to look at the heating requirements, we can go for the room losses. Now this is presented slightly differently in that you get a list of all your spaces, and you can then go into the space of interest, and this gives you a breakdown of the fabric loss, infiltration and ventilation losses, the mean, and the usual figures such as watts per meter squared, watts per meter cubed. And you can view the details, which gives you a breakdown of the heat loss across all the various partitions. So the program will automatically look at the temperature of the rooms next door and allocate a delta T across each face and then give the appropriate loss or gain to the space. If from a perspective and a standpoint of heat losses, you get a negative loss. That's effectively a gain, which we're not seeing in this instance. This also gives you the F1 and F2 correction factors in line with A5, the internal losses, the ventilation losses, and the total losses. Now let's go and see what happens when we start pre-treating the air. We go to the Edit menu, we select General Plant, we then go to the Heating tab, tick the box, and I'm going to have my off-call condition of 13 degrees. And we'll apply cooling, tick the box, and let's say again we'll have an off-call condition of say 14 degrees. OK. Select the room space, revisit the answers, display individual room gains. Now we're getting a totally different profile. You can see now, because we're treating the air, that's having a bearing on the profiling of the space. And when we view numerically now, we're now getting a peak of 2793 as opposed to 10.9 kilowatts. And we can review that for August, 3098, and September, 3077. So obviously August is the peak. So if we are treating the air, August is still the peak. If I want to treat the ventilated air into the space for fresh air requirements, I still need a fan coil unit, DX system, split, or whatever, of just over 3 kilowatts to bring that room down to the desired temperature that we've got in the room profile of 22 or 23 degrees. The summertime temperature can also be viewed. We're now getting a cooling effect. It was 43 degrees, now 36 degrees. If we apply that extra 3 kilowatts of cooling, that will also bring the room down to the specified 22, 23 degree set point which we've applied. Looking at the room losses again, going into the same space, we basically halved it. Going into the details, and you can see now we've only got 3.445. So again, if we're putting radiators or a wet system in or a fan coil unit, we now have to offset 3.445 kilowatts in order to maintain that room at 21 degrees. We can look at our room gains collectively. You can see here, it then just updates the calculation and run the room gains check, where we then get a summary which we can be viewed. And then we can see the summary of all our room spaces, giving us our sensible, latent and our volume flow rate requirements.